Welcome all of you. Now this is going to be a quick video to clear all your doubts regarding IUPAC nomenclature in organic compounds. This is only till the class 10th syllabus. Please don't take it for class 11th and 12th. Okay, so this is only till class 10th where you are asked to name aliphatic compounds. Okay. Now here I will not go into the different rules that you have, but with the help of examples we'll complete the entire nomenclature. So you'll be in a very good position to do any nomenclature that comes in your exam after this. So let me give you a few examples, but before I start with examples, I want to say something that you should have a basic idea of what are alkanes, what are alkenes, what are alkynes, okay, what are the functional groups, what is a methyl group and what's an ethyl group. So let's first talk about that. Okay, so here alkenes are the saturated hydrocarbons, okay, and they are made out of CH4. Let's take CH4, okay, so they are made out of all single bonds, CH4, single bonds everywhere, okay, C2H6. So here I have note here, okay, how many hydrogens do I have? I have 6 hydrogens, that is C2H6. So these are all alkenes, that is the bond between, I'll go to the third one also, that is C3H8, okay, C3H8, that is propane. So C3, okay, and H8. So this is propane. Now since carbon has valency 4, so every time we'll have 4 of these lines. So this is C3H8. Okay, so these are all alkanes. Now when we say alkanes, anes, okay, from alkanes. So when we say this, we have to note this alkanes, and what is important to note here is between carbon and carbon. Now here also people misunderstand. Between carbon and carbon there has to be a single bond. Then it is an alkene. Okay. So it follows the general formula CnH2n plus 2. You can note here C3H after 2 into 3 6 plus 2 8. C1 here you put 1. Okay. C1 here you put 1. That means CH4, or you can even write C2H6. So this is the general formula for alkanes. So this basic idea, and then the idea for alkenes and alkynes, that also you should have. The idea of alkenes. Okay, alkenes. Now alkenes have how many? Alkenes have a double bond between carbon and carbon. Okay, they are unsaturated hydrocarbons, and alkynes, they have a triple bond between carbon and carbon. Apart from this, we have the functional groups. So we have the functional group COOH, that is carboxylic group. Okay, carboxylic group. Then we have the CHO, that is the aldehyde. Okay, we have the aldehyde, and then we have the OH, which is the hydroxyl group. So I am going to do only the things that generally are asked, hydroxyl, okay, OH. And then we have the C2H5, which is the ethyl group. This is not ethyl group is not a functional group. It is treated as a substituent, okay. CH3, that is methyl group. Okay, this is methyl group. Now knowing this is very important in order to continue. What else do we need to know? We need to know carbon has a valency of 4, oxygen has a valency of 2, and hydrogen has a valency of 1. These things also we have to know before we start with our nomenclature. Okay, so now in nomenclature, let's see, we'll take examples. There are 5 rules, but then as I proceed with them, I'll not teach the rules separately. As I proceed with the examples, I'll talk about the rules. Now if you see this, okay, now here first thing what we have to check, the moment we get this kind of a structure, what we have to check, okay, firstly we'll have to check the bonds. Is there any double bond in this? Okay, they are all single bonds. Second thing, which is the longest chain and which is the branch, we'll have to recognize. So here, this is the longest chain, okay, the longest straight chain we'll have to recognize, okay, and this becomes a branch. In the long chain, we have 1, 2, 3, 4. How many carbon atoms we have? 4. So, another thing that I want to tell, if you have only one carbon, okay, in the parent chain, in the main chain, okay, then you call it is named as meth. If you have two carbons in the parent chain, you call it as eth, like in ethane, okay. In methane, there's just one carbon. If you have three carbons, so 1 meth, 2 eth, 3 is a prop, okay, 3 carbons, then you call it as prop, okay. So 4 carbons and you call it as bute, you'll see as I do the naming. 5 carbons becomes a pent and 6 carbons becomes a hex, okay. 7 carbons become a hept, okay. We don't need actually beyond that. So hept, and then you have oct, and then after oct you have non and deca. So but then you don't need actually beyond this. Now here in this one we have 1, 2, 3, 4. This is the main chain, okay. This is the branch. It is also called the substituent. So you have to recognize the main chain and the branch, okay. So here this is the main chain. So how many carbons? 4, and all single bonds. So the first thing we start noting is it all single bond or not? Okay, it is all single bond. So first thing is it is a bute. Definitely it's a bute. Single bond makes it a ane, butane. But then I have the substituent. I didn't talk about it. So let us start numbering. Okay, now the side in which the substituent, the closer side, this is closer to the substituent. This carbon is not close to the substituent. This is close to the substituent. So from this side, we will start numbering 1, 2, 3, 4. Okay, so we have numbered. So it is 2 methyl, okay, 2 methyl butane. Why 2 methyl butane? Because this methyl group is attached to the second carbon atom. That is why 2 methyl butane. Okay, let's see more examples. Now here if I see this, I can take this also as the long chain or this also as the parent chain, whichever, any one side, because they are the same. It is very symmetrical. So any one, if I take this, then this is also, you know, whether I number it 1, 2, 3 or 1, 2, 3, this is going to come 2 only. So from any one side I am numbering. These two become the substituent. Methyl groups, they become the substituent. So here 1, 2, 3. Okay, now this is methyl group. How many methyl groups? There are 2 methyl groups. To which carbon atom? To the second. Are all the carbons linked with single bonds? Yes. How many carbon atoms are there in the main chain? 3. So this becomes a prop. So it's a propane. Prop because of 3 carbons, ane because of single bonds. Okay, and then let's come to propane, and then let's come to the rest part of it, the substituent. This is 2. To the second carbon, how many methyl groups are there? There are 2 methyl groups both to the second carbon. So how we'll write? 2, 2. Why 2, 2? Means this 2 and this 2 are indicating the second carbon atom. Dimethyl. Okay, dimethyl propane. Why di? Because there are 2 methyls only. Okay, both are methyl groups, so dimethyl. Okay, if there are 3 methyl groups, we will say trimethyl group. So dimethyl propane. So that is how we name it. And this has to be written in front only. Here, this is the long chain. Okay, how many carbons in the long chain? Okay, 1, 2, 3. 3 carbons in the long chain. So If it is 3 carbons in the long chain, it becomes a prop. Okay, it becomes a prop. But whether it is ene or ine or ane, we'll see. Carbon carbon, there is one single bond. Now you should not think that this carbon carbon does not have a double bond. It is only one set of carbon carbon will have that double bond, and that will give you that name. Don't look for that double bond in more than one number of carbon atoms. It will be only at one place. So double bond, that indicates ene, okay, not ine, ene, okay, and then there's nothing else that we need to tell in this. So this is just prop and ene. Now here I have, this is the long chain, okay. First thing is, this can't be the long chain. This only has to be the long chain because it has 3, this has 2, okay. Now in this chain here, this is a double bond. So we've got a double bond, we have got 3 carbons, that makes it propene, right? Propene, ene for the double bond, prop for the 3 carbons. Now we'll have to name it. Now this is the double bond, so we will start naming it from this end, okay. 1, 2, 3. The side which has, now this is one important thing, the side which has the double bond gets the carbon number 1, okay. This will not get 1, okay. Now here how will we do the rest of the naming? This substituent, which is the methyl group, is attached to the second carbon, so we will say 2-methyl propene, okay. That is our name, 2-methyl propene. This 2 is for the second carbon atom, so this methyl group is attached to the second carbon, so 2-methyl, okay. Now here, this is our long chain, definitely, okay. There are 7, 1, 2, 3, 4, 5, 6 and 7 carbons. Now this substituent, these are the substituents, the methyl groups are closer to this carbon, so this will get number 1, yes. And then if this gets number 1, this is the third carbon to which this is attached. To the fourth carbon, this methyl group is attached. These are substituents. Now are all single bond or not? Yes, all are single bond, okay. That also we have to see. So first thing, 7 carbons, hept, all single bonds in, okay. 7 carbons, hept, all single bonds in. This is to the third carbon, which is 3-methyl, okay. This is 1 methyl, this is another methyl, so we will write 3, 4, 1 to the third one, 1 to the fourth one, dimethyl, okay, dimethyl, because both are methyl, dimethyl heptate, okay. So this is our final answer. This is the answer. So here I have, the long chain is definitely this, 1, 2, 3, 4. So that makes it a bute. All single bonds, that makes it a ane, okay. Now here I have 4 of methyl groups, 4 methyl groups, and you can do the naming from any one side because it is, whether you do it 1, 2, 3, 4 or 1, 2, 3, 4, it's the same, it is very symmetrical. So it makes no difference. Now this is the second carbon. So how do we name it? We will name 2, 2 because there are 2 of methyls. 3, 3, okay. 2, 2, 3, 3, then what? Tetra, 4 makes a tetra. Tetra methyl butane, okay. 3, 3, 4, 4 tetra, sorry, 2, 2, 3, 3 tetra methyl butane. 4 methyl groups are there, that makes it tetra. Now here is the next one. Now there is no branch here, only the parent chain, 1, 2, 3, 4, 5. Why did I name it 1? Because the double bond is closer to this end, double bond closer to this end. So I named this one and not this as 1. 1, 2, 3, 4, 5. So that makes it a pent. But then there is a double bond. That makes it ene. But then we'll have to talk about the double bond also, because where exactly is the double bond lying? So the double bond is with the second carbon. Okay, so it is with the second carbon. So we are going to write it as 2-ene. Pent 2-ene. This, when we write it not in front, but when we write it like this, it shows the position of the double bond. Okay, so this is the position of the double bond, the pent 2-ene. So this, now here you should not think that the carbon is linked to the third one also. Why am I writing 2? Now when you are coming from this side, 2 comes first, so it is linked to the second one only, we will say. That is, it is just a system. Okay, it is of course linked to the third carbon atom also, but while naming we'll say that it is only linked to the, that it is pent 2 in, means the second carbon atom has the double bond. Okay, so now here I have no branches here. Okay, 1 2 3 4, 4 of them, that makes it a but. Triple bond, that makes it a ine. Okay, but then to the first, I will start numbering from this side because bond, triple bond is this side, and so to the first, but 1 ine. Okay, that was our first ine question. This is again another one. All single bonds, 1 2 3 4, parent chain, but. Okay, ane, right? It's an ane, butane, and then these are substituents, but they are halogens. They don't come under functional groups. Chloro, bromo, these are substituents. So now to which carbon is the substituents linked to the second? Because chlorine is here, so we will number like this. So if we will number the carbon atoms from the side where they have the double bonds, we'll number the carbon atoms from the side they have the triple bonds, from the side they have the functional groups, or even from the side they have the chlorine or bromine substituents, methyl groups. From that side we start numbering. Okay, so from the side which is closer to the substituents or the functional groups. So butane. Okay, but then what to do about this? So here we are going to write 2 2 because both to the second carbon, dichloro, 2 2 dichloro butane. Okay, di because there are 2 chlorines, and then chloro is for chlorine. Keep watching the video till the end, because at the end I am going to do a very special kind of naming, which can be sometimes very confusing to you all. So that I am doing towards the end of the video. Now this is having a functional group OH. This is the parent chain, longest carbon chain, and then it has a functional group OH. Okay, so first thing is it becomes a prop. It becomes a prop, but then it's not an ane. It has OH. Okay, now if you count the carbon chains, so from this side or that side is going to be same, only this is going to remain 2 only. So prop. Now we are going to name it as propan 2 all. Okay, so 2 telling us that from the second carbon atom the OH group is linked. Okay, but what about this? Okay, so that is 2 methyl. Okay, that is to the second carbon atom we have 1 methyl group, methyl propan 2 all. Okay, so methyl for the CH3, 2 for the second carbon, propan for the 3 carbons. Okay, all for the OH group. Now this is our next sum. This is our next question. Now this is something different we can see here. Okay, now here 1 2 3 and 4, that makes it but. Okay, 4 carbons. Then here we have the functional group. What is the functional group? The functional group is actually this CHO, which is written like this. So you will have to recognize this functional group. This is for aldehydes. Okay, for the homologous series of aldehydes. So now if the functional group is at the end, then we don't number it. It is at the end to the first carbon. So butanal, al, note it is al. It is all for alcohols, al for aldehydes. Okay, butanal. So here we have another one which has a substituent. Okay, this is the long chain. Functional group is here 1, 2, 3, 4. We start naming from the functional group. Okay, functional group is again one CHO group. It is clearly one aldehyde. Okay, now it is 1, 2, 3, 4, which makes it a butanal. But then we have this 3-methyl butanal. Now here is one question that might arise in your mind. If the functional group itself has a C, should we count it in the long chain and in the naming? Yes, we count it. We count that 1, 2, 3, 4. You can see clearly to make it but, we have taken it. Okay, so let's take one sum with carboxylic acid. Now here long chain 1, 2, 3, 4, 5. Functional group is here 1, 2, 3, 4, 5. This is for carboxylic acid, you can see. So it is clearly pentanoic. As I said, the carbon of the functional group is also included. Pentanoic acid. But then what to do about this? This is 1, 2, 3. 3-chloropentanoic acid is the name. Okay. So we start numbering from the functional group and we include the carbon of the functional group. Now here are two examples. Now this is what I was talking about. You can have a lot of confusion in this. If there is a chlorine and there is a CH3, now both are substituents. Which should I number 1, 2, 3, 4 from that side or from this side? Okay. So I should still number from the closest side. I will still number from the side, from the nearest end. Means chlorine is closest to this, I will number from here. CH3 is far from this, I will not number from here. Okay, so I will not think whether it is chlorine or CH3. I will simply number from here. That's it. Okay. Now, coming to the naming part of it, this is chloro, this is methyl. Then I will follow the alphabetical system. Then it is 1, 2, 3, 4, 5, 6. It's a hexane. All single bonds, it's a hexane. Right? And then this is 2-chloro. Chlorine C, methyl M comes later. So it is 2-chloro, 3-methyl, okay, hexane. So I am following the alphabetical order. But then numbering has to come to the closest one. Whichever is closest to the end, from that side we start numbering. Here again we will start numbering from this side because this is far. So we will start numbering 1, 2, 3, 4, 5 and 6. Hexane clearly because this is only single bonds and 6 carbons. But then this is 2-methyl, 4-ethyl. But then what to do now? Okay, we will write 4-ethyl, even though this number is bigger, but because of E of ethyl, okay, and then 2-methyl. 2-methyl what? Methyl hexane. So note this alphabetical thing also. If I have chlorine and bromine, then bromine will be named first, bromine will be written first, then chlorine will be written. Number can be, number can be 3 for bromine and 2 for chlorine, but bromine gets written first and then chlorine. Okay. So that is it with this video. Maybe you have got a little better idea about IUPAC nomenclature. Okay, so you are not asked to write the names of the rules that you are learning. There are some 5 rules here which is followed, but then you just have to learn to name them and you'll get all your naming correct once you watch this video. So that's it. Let me know if you like the video and you can put down a comment if you have liked the video. Also do not forget to subscribe the video if you haven't subscribed. Also do not forget to subscribe the channel if you haven't subscribed by now. Thanks then. Bye all of you.